Morning, everyone. So we are connected with virtual here now again. Today we will be going to start a unit step function. So next. Today we will be dealing with a topic of unit step function. So today we have unit step function. One second. Unit step function. Unit step function. Unit step function is a new topic here for you. So next continuation. So unit step function. Hang out the unit step function definition. First we will start with the definition. Definition note this function is denoted by u of t minus a. It is denoted by u of t minus a, and also it is denoted by, and it is defined as u of t minus a is equal to 0 to 1 if t is less than a, 1 if t is greater than or equal to a. So ಇದೊಂದು unit step function and define ಮಾಡ್ತೀವಿ. So this function is denoted by u of t minus a. ಈ function ಹೆಂಗೆ ಡಿನೋಟ್ ಮಾಡೋದು ಅಂತ t minus u of t minus a ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. And how we hand define ಮಾಡ್ತಿದಾರ u of t minus a. Okay, u of t minus a is equal to 0 if t is less than a, 1 if t is greater than or equal to a. So u of t ಯಾವಾಗ function define ಆಗ್ತದ್ರ 0 is less 0 t ಗಿಂತ less than 0 ಇದ್ದಾಗ t less than a ಇರಬೇಕು, and 1 if 1 ಇದ್ದಾಗ t is greater than or equal to a ಇರಬೇಕು. So as usually graph denote ಮಾಡಿದ್ರೆ, if we denote the graph from this, we come to know that if we denote a graph to this, we come to know that let us assume x-axis as a t and y-axis as a u of t minus a. Okay, u of t minus a. So by the definition we consider this: if u of t minus a is equal to 0 if t is less than or equal to, if 0 if t is less than a. So we'll consider ಮಾಡ್ರಿ exercise ಆಯ್ತಾ. So let us consider if 0 let us consider a ಅಂತ consider ಮಾಡ್ರಿ point. So next ನೋಡ್ರಿ 0 if t is less than a. So t is less than a ಇದ್ದಾಗ is the initial point 0 ಅಂತವ್ರಿ. So t less than is 0 point ಅಲ್ಲಿ ಇಲ್ಲಿ ಡಿನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. So next y axis ನಾಗ ಏನಂತ್ರಿ u of t minus a. So let us denote in next 1 if t is greater than or equal to a. ಇಲ್ಲಿ 1 ಅಂತ ಡಿನೋಟ್ ಮಾಡಿದಾಗ so ನಾವು ಯಾವ ಪಾಯಿಂಟ್ ಬರ್ತದೆ ಅಂದ್ರೆ a is less than or equal to here t is less than a if 0 ಇದ್ದಾಗ 0 ಇದ್ದಾಗ t is less than a ಅಂತ ಇಲ್ಲಿ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. ಇದನ್ನು ಪಾಯಿಂಟ್ ತೋರಿ, ಇದನ್ನು ಪಾಯಿಂಟ್ ತೋರಿ, ಈ ಪಾಯಿಂಟ್ ತೋರಿ. ನೆಕ್ಸ್ಟ್ ಈ ಪಾಯಿಂಟ್ 1 ಅನ್ನು ಇಲ್ಲಿ ಅಕ್ಯುರೇಟ್ ಸೊ ಯಾಕಂದ್ರೆ 0 is 0 ಇದ್ದಾಗ t is less than a ಇದ್ದಾಗ ಇಲ್ಲೇ ಪಾಯಿಂಟ್ ಇನಿಷಿಯಲ್ ಇರುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ 1 ಇದ್ದಾಗ if t is greater than or equal to a ಇದ್ದಾಗ 1 ಡಿನೋಟ್ ಮಾಡಿದ್ರೆ ಇದು ಅಕ್ಯುರೇಟ್ ಆಗಿ ಮುಂದಕ್ಕೆ ಹೋಗ್ತದೆ. So this is how we define the unit step function. Okay, this is how we define unit step function. Okay, so next is the next one second. So understand unit step function. Unit step function. This is a function. This function is denoted by u of t minus a. Okay, and it is defined as u of t minus a is equal to 0 if 0 if t is less than a, 1 if t is greater than or equal to a. By seeing this graph, we can say that so the initial value 0 tondiri. So x-axis naga let us take t and y-axis as u of t minus a. Okay, u of t minus a and consider one for it. So let us assume first point nodri idu 0 iddaga t is less than a ada. So 0 initial point naga a and one point consider ಮಾಡ್ಕೊರಿ. a denote ಮಾಡಿದಾಗ a initial as well as 1 if t is greater than or equal to a. So t is greater than or equal to a iddaga one point ತಗೊಂಡಿದ್ದೀವಿ. So we mention here it as dotted line, then it will be a straight line for you. So 1 point only. So 1 and t denote ಮಾಡಿದಾಗ ಈ ರೀತಿ ತಗೊಂಡಿದ್ದೀವಿ. Okay, so next slide one next nodri one note point alli let's consider a note point here. So let us consider a note point. So previous problem alli ittu so previous problem alli if t a is equal to if t is less than or a to as well as t is greater than or equal to a. So now let us small functions, right? Okay, so previous problem if a is less than a and t is greater than or equal to a. So now let us consider one note point only. If a is equal to 0, let us consider a is equal to 0, then let us assume so t previous problem previous question as if our definition says u of t minus a is equal to 0 if t is less than a, 1 if t is greater than or equal to a. So e condition apply. So now we are applying is if t is equal if a is equal to 0, then what will be happening? U of t. Okay, u of t, then 0 if t is less than 0. Okay, so 1 is 1. So 1 and 2 nodri 1 ಅಂತ ಇದು ಏನೋ 1 if t is greater than or equal to 0. T is greater than or equal to 0. So what we have did change ಮಾಡಿ ನೋಡ್ಕೊಳ್ಳಿ. So one note point next to note point ನಾಗ ಒಂದು example ತಗೊಂಡಿವಿ. If a is equal to 0, then so ಏನಾಗ್ತದ u of t ಆಗ್ತದ. So because u of t of minus 0 is nothing but u of t, then 0 if t is less than 0, 1 if t is greater than or equal to 0. So for this we have seen graph means what will be the graph for this. Let us consider. So let us see a graph for this. So this x-axis we need to know here. Okay, At y-axis u of t we are writing here, and at x-axis we are writing t here. Then this is an initial point mentioning O. Okay, so then let us see here. 0 if t is less than 0. So t is less than 0 idaga idi cut point barutte. Okay na, idi ikkada barutte point. So as usually, if 1 if t is greater than or equal to 0 anta. So let us consider here as a 1 point. So 1 idaga t if 1 if t is greater than or equal to 0. So greater than or equal to 0 idaga ee points ಮೇಲೆ shift ಆಗ್ತಾ ಇರ್ತವೆ. Means here something here, lower point row. So we are assuming only 1 here, 1 if t is greater than or equal to 0. So like this we denote the unit step function. ಇದಕ್ಕೆ ಯಾಕೆ ಯೂನಿಟ್ ಸ್ಟೆಪ್ ಫಂಕ್ಷನ್ ಕರೆದ್ರು ಅಂದ್ರ, ಸೊ ಇಲ್ಲಿ ನೋಡ್ರಿ ಇದು ಹೆಂಗ್ ಸ್ಟೆಪ್ ತರ ಬಂದಿದಲ್ಲ. ಸೊ ದಿಸ್ ಇಸ್ ಯಾವ ತರ ಸ್ಟೆಪ್ ತರ ಬಂದಿದಲ್ಲ. ಸೊ ಇದಕ್ಕೆ ನಾವು they assumed as unit step function. Okay, that. So 1 second, we'll go for next theorem. Okay, so next we'll go for theorem point of view here. So next is Laplace transform of unit step function. Laplace transform of unit step functions. Laplace transform of unit step function. Laplace transform of unit step function. That is, we have to prove here is L of u L of u of t minus a is equal to e to the power of minus as divided by yes, we have to do this. Okay, so in the definition, same definition u or as if from definition in the u of t minus a is equal to e to the power of minus as divided by s. We have to prove this. So for proving this, so I prove ಮಾಡಬೇಕಂದ್ರೆ, so by the definition of Laplace transform, by definition of Laplace transform, by definition of Laplace transform, we have L of u of t minus L of u of t minus a is equal to integration 0 to infinity e to the power of minus st f of t into dt. So as usually given formula. So Laplace transformation formula ee tarane written madutte. Okay, so by the definition of Laplace transform we are taking this formula. So next ya assume ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ, so ಇಲ್ಲಿ ಎರಡು functions are already. So already by definition of unit step function we are having two formulas, that is two conditions. So first let's definition ಬರ್ಕೊಂಡು start ಮಾಡೋಣ. 0 to infinity e to the power of minus st f of t dt. Okay. So next, as usually, chain condition of 0 to infinity e to the power of minus st. So first condition, u of t minus a, u of t minus a into dt plus integration, sorry, you know, right? 0 to a to infinity. So 0 to a to infinity, that is e to the power of minus st u of t minus a into dt. So by the definition of unit step function, we can come across that two conditions of these. So that is u in integration 0 to a e to the power of minus st into e to the power of minus st u into t minus a into dt plus integration a to infinity e to the power of minus st u into t minus a into dt. Okay, so this is how. So next we put the conditions for this. So 0 to a e to the power of minus st. So first condition in the integration andu, let us see this. So first condition in the number 0 if t is less than a. So first condition in the 0 okay na 0. So 0 e to the power of minus u minus at will be that equal to 0 into dt plus 0 a into a to the power a integration a to infinity e to the power of minus st. So condition for u, second term again, ut minus a is 1 into dt. So next, this whole term will be 0, then plus the whole term will be 0, then plus integration a to infinity e to the power of minus st. So e to the power of minus st, that is into dt. Okay. So first we will consider the Laplace transformation definition here. Then we apply that definition, that expression here, 0 to a e to the power of minus st u into t minus a into dt. So u of t minus a is the given term, f of t ಇದೆ ನಮಗೆ. So our conditions ನೋಡಿರಿ. So that is condition into dt. So second condition, integration a to infinity e to the power of minus st u of t minus a into dt. So these are the two conditions we have to match, because the condition here in the definition is there are two conditions: 0 if t is less than a, 1 if t is greater than or equal to a. So these both the conditions we have to match in the theorem here. So for that condition, so u minus t for the first condition is 0 and for second condition is 1. So next we have considered this whole term will be 0, then the remaining term integration a to infinity e to the power of minus st dt will be remaining. So in next slide, So in next slide we will be accepting here 0 plus if we integrate, once again, if we integrate this, what will be our answers? If we integrate this whole term, we will be getting e to the power of minus st divided by minus s with a limit of infinity to a. Okay. So this only will be getting in next step. Okay. So 0 plus we have integrated that e to the power of minus st divided by minus s infinity to a. Okay, so this will be the remaining part of us. So then we may consider that will be remaining applying limits, now applying applying limits. Now we apply the limits. So one limit is e to the power of minus s infinity. So what term will be here minus s then plus of the whole term will be then plus remain this term minus, so minus of minus will be plus, so minus of minus will be plus, then e to the power of minus s a divided by s. So this whole term will be get cancelled. 0 plus e to the power of minus s a divided by s. The last term will be remaining for you is e to the power of minus s a divided by s. Okay, the final answer we get final after the deriving this theorem we will be getting L of u of t minus a, that is equal to e to the power of minus s a divided by s. Okay, this is the derivation of Laplace transform of unit step functions. Okay, this is the derivation of Laplace transform of unit step functions. We may mention this. Okay, so next we will be revising once again this by the slide number 3. So the theorem for today's topic is Laplace transform of unit step function. We have to prove that L of u of t minus a is equal to e to the power of minus as divided by s. Okay, so by the definition, now proof, by the definition of Laplace transform, we have L of f of t is equal to, means I will be saying L of f of t is equal to integration 0 to infinity e to the power of minus st f of t into dt. So same ಇದರ ಪ್ಲೇನೆ ಇದನ್ನು ಬರ್ಕೊಂಡಿವಿ. So f of t value ಏನು ನಮಗೆ u of t minus a f of t value. So u ಈಗ f of t value ಏನು ನಮಗೆ u of t minus a f of t value. So next we apply for this in a next slide we will see here. So next slide ಬಂದಾಗ so f of t value ಏನು ನಮ್ಮದು u of t minus a. Okay na? So integration 0 to a e to the power of minus st u of t minus a into dt plus a to infinity e to the power of minus st u of t minus a into dt. Okay na? Idu namdu as a standard derivations. So derivation ಮಾಡಿ. So applying derivative, applying Laplace transformation definition apply ಮಾಡಿ ಈ statement ಬರ್ಕೊಂಡು. So next ಏನು ಮಾಡ್ತೀವಿ 0 to a e to the power of minus st 0 into dt. So 0 into dt ಏನು ಬರೆಯೋಣ by the definition of considering the definition 0 if t is less than a. First condition prove ಮಾಡ್ಕೊಳ್ತೀವಿ ಇಲ್ಲಿ. So first condition prove ಮಾಡ್ಕೊಂಡಿದ್ದಾಗ it's term 0 ಆಗ್ತದೆ. So next term ಏನಂತ e to the power of minus st 1 into dt. Second term ಏನು ನಮಗೆ by definition ಇದು 1 t is greater than or equal to a. Okay, so this whole term will be becoming 0 for you. Then e term ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ a to infinity e to the power of minus st into dt ಇರುತ್ತೆ. So next ಇದಕ್ಕೆ integration ಮಾಡಿದಾಗ ಏನಾಗ್ತದೆ e to the power of minus st divided by minus s. So limits are infinity to a. So next slide is about, so ಈ term ಪೂರಾ 0 ಆಗ್ತದೆ. So next term e to the power of minus st divided by minus s infinity to a ಹೋಗುತ್ತೆ, a to infinity ಹೋಗುತ್ತೆ. So then ಇದಕ್ಕೆ ಅಪ್ಲೈ ಮಾಡಿದಾಗ previous whole time one term ಪೂರಾ 0 ಆಗ್ತದೆ because e to the power of minus infinity ಆಗ್ತದೆ. e to the power of minus infinity means e to the power of minus infinity, that is infinity, the whole term is becomes 0. ಅಲ್ಲಿ consider ಈ part ಪೂರಾ ಏನು ನಾವು consider ಮಾಡಿ. So remaining part ಏನಾದ್ರು e to the power of minus sa divided by s ಹೋಯ್ತು. So minus s ಆಗ್ತದೆ. So because e to the power of minus sa divided by s. So we have proved this L of u of t minus a is equal to e to the power of minus sa divided by s. This is your unit step function, first step. So next, second one. Okay, now let us consider with property number 6, that is second shifting property. So it is in the second shifting property. So second shifting property, second shifting property. Second shifting property. Okay. So second shifting property. So second shifting property means what does the statement says? So statement so statement if L of f of t. So what does the statement says? If statement if L of f of t is equal to f of s, then what we have to prove means here. So ಏನು prove ಮಾಡಕಂದ್ರ L of f of t minus a into u of t minus a of 2 dt. So you have to prove this. The conditions use ಮಾಡ್ಕೊಂಡು ಇದು f of t ಅಂತ ಹೇಳಿ ತಗೊಂಡು ನಾವು ಪ್ರೂವ್ ಮಾಡಬೇಕು. So second shifting property ಏನಂದ್ರೆ let if the statement ಏನಂದ್ರೆ if L of f of t is equal to f of s. So obviously we know that L of f of t is equal to f of s. Then we have to prove that L of f of t minus a into u of t minus a. Okay, u is we don't confuse this. ಇದು ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೋಬೇಡ್ರಿ, ಇದು u ಆಗಿರುತ್ತೆ. ಸೊ ಏನ್ ಪ್ರೂವ್ ಮಾಡಕ್ಕೆ ಏನ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು f of t ಏನಿದೆ ಅಂದ್ರೆ L of f of t minus a into u of t minus a into dt. So this is your f of t. So next we will be going through this from theorem. L of f of t minus a into u t minus a is equal to integration 0 to infinity e to the power of minus st f of t minus a into u of t minus a into u of t minus a. So now we shall consider these two terms in a splitting terms. So next term. So from here I will be pretending to you. So 0 to a, L split account. So 0 to a to infinity. So this is how our unit step function works here. So 0 to a to the power of minus st, then f of t minus a into u of t minus a into dt. Okay. So next, either integration is 0 to a. So next, the a to infinity. Okay, na? A to infinity. So a to infinity daga e to the power of minus st, then f of t minus a into u of t minus a. Okay, this close the bracket and into dt. We splitted these terms into 0 to a to infinity, because so f of t jati u in u of t minus a jati a multiply agari f of t minus a multiply agara. So illadke ಎರಡು ಸ್ಪ್ಲಿಟಿಂಗ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಗಿ ಮಾಡ್ಕೊಂಡಿವಿ. ಸೊ ಯೂನಿಟ್ ಸ್ಟೆಪ್ ಫಂಕ್ಷನ್ ಆಗ ಎಲ್ಲದಕ್ಕೂ ಒಂದು 0 ನಿಂದ ಬರ್ತದೆ ಒಂದು a ನಿಂದ ಡಿನೋಟ್ ಆಗ್ತದೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ನೋಡ್ರಿ, I think we will observe this. The next step, that is equal to, so 0 to a e to the power of minus st. So f of t is part of f of t minus a. So f of t minus a, that the term noted previous term ಬರ್ಕೋಬೇಕಾಗ್ತದೆ. 1 second wait ಮಾಡಿ. So previous term ಬರ್ಕೊಮ್ಮಿ 0 to a 0 to sorry 0 to infinity e to the power of minus st. Previous term into f of t minus f of t minus a into u of t minus a into dt plus integration dA right? a to infinity ga. So next nodri e to the power of minus st barutte, then f of t minus a irutte. So next into I am writing here multiplication, this is multiplication, that is I am writing u of t minus a into dt into dt. The whole term I am writing next. So ಇದೆಲ್ಲನೂ ಕೂಡ ತಾಗ ಬಂದಿಟ್ಟಿದೆ ನೋಡ್ಕೊಳ್ಳಿ. So next step ಅಲ್ಲಿ u into ut minus a into dt. ಓಕೆನಾ? ಸೊ ಇದು previous step ಅಲ್ಲಿ ಇದಿಷ್ಟೆಲ್ಲನೂ ಡಿನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಈಗ ಇದು ವ್ಯಾಲ್ಯೂಸ್ ಪುಟ್ ಮಾಡಬೇಕು. ಸೊ ನೆಕ್ಸ್ಟ್ ಈಗ ವ್ಯಾಲ್ಯೂಸ್ ಪುಟ್ ಮಾಡಬೇಕು. 0 to a e to the power of minus st. So here we put the values of ut minus a. Okay, so ut minus a is f of t minus a into, so this value of ut minus a is 0 because from the definition of unit step function. Okay, so into dt. So next here in the next integration a to infinity there, okay na, e to the power of minus st as it is. Now let us see here f of t as it is t minus a. So u of t value, the inner term in the value 1 ಆಗಿರುತ್ತೆ. So into dt. So next we observe this whole term as 0. So whole term as 0. So plus a to infinity ada ಏನು value e to the power of minus st ಉಳಿಯುತ್ತೆ. So then f of t minus a ಉಳಿಯುತ್ತೆ. Okay na? Then dt ಉಳಿಯುತ್ತೆ. Okay na? This remains last two. So next ಇದಕ್ಕೆ equation 1 ಅಂತ. Okay na? ಇದಕ್ಕೆ equation 1 ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ equation 1 ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ so ಏನಾಗುತ್ತೆ ನಮಗೆ ನೆಕ್ಸ್ಟ್. So let's put the values. So ನೋಡ್ರಿ ut minus a ಅದ. ಓಕೆನಾ? ಇಲ್ಲಿ ಏನದ ನಂಗೆ a to infinity ಅದ. So obviously ಲಿಮಿಟ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್ ಅಲ್ಲಿ ಇದು ಚೇಂಜ್ ಆಗಬೇಕು. ನಮಗ LFT ಪ್ರಕಾರ LT ಪ್ರಕಾರ 0 to infinity ಇರಬೇಕು ಯಾವಾಗಲೂ. ಸೊ ಅದಕ್ಕೆ ಆ ಲಿಮಿಟ್ಸ್ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳೋದ ಆಸ್ ಯೂಶುವಲ್ ಇಲ್ಲಿ t minus a ಯೂಸ್ ಮಾಡ್ಕೊತೀವಿ ನಾವು. ಈಗ ಹೆಂಗಪ್ಪ ಅಂದ್ರೆ t minus a is equal to v ಅಂತ ಪುಟ್ ಮಾಡ್ಕೊತೀವಿ. t minus a is equal to v, then obviously so next ನೋಡ್ರಿ put ಇನ್ನೊಂದು ವ್ಯಾಲ್ಯೂ t is equal to a is equal to t ಅಂತ ಪುಟ್ ಮಾಡ್ಕೊಂಡ್ರಲ್ಲ t is equal to a ಅಂತ ಪುಟ್ ಮಾಡ್ಕೊಂಡಾಗ ಸೊ ನಮಗೆ ಲಿಮಿಟ್ಸ್ ಬರ್ತದೆ ಇಲ್ಲಿ. ಸೊ ಲಿಮಿಟ್ಸ್ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, ಇಲ್ಲಿ t is equal to a ಅನ್ಕೊಳ್ಳಿ ಮತ್ತೊಂದ್ಸಲ. ಸೊ a minus a is equal to b ಆಗಿ ಇವಾಗ ಕೆಳಗಿನ ಲಿಮಿಟ್ಸ್ b is equal to 0 ಆಗಿರ್ತದೆ. ಸೊ b is equal to 0. obviously malin limits t limits ಏನಂದ್ರೆ ಅದು ಇನ್ಫಿನಿಟಿ ಅದ obviously ಕೆಳಗಿನ b limits ಏನಾಗ್ತದ ಇನ್ಫಿನಿಟಿ obviously ಆಗ್ತದೆ ಸೊ ಅದರ ಪ್ರಕಾರ ಸೊ dt is equal to dv ಆಗ್ತದೆ ಸೊ ಇದಕ್ಕೆ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ಕೊಂಡ್ರಂದ್ರ ನಮಗೆ ಏನು ಉಳಿತದ dt is equal to dv ರಿಮೈನ್ ಆಗ್ತದೆ obviously v is equal to 0 ಆಗಿದೆ v is equal to 0 ಆಗಿದೆ so t is equal to infinity then t is equal to infinity the obviously v ನು ಏನಾಗಿರ್ತದ ಇನ್ಫಿನಿಟಿ ಆಗಿರ್ತದೆ ಓಕೆನಾ ಸೊ ಫಸ್ಟ್ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ನಾವು t minus a is equal to v then t is equal to a ಅಂತ ಪುಟ್ ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರು ಸೊ t is equal to a ಅಂತ ಪುಟ್ ಮಾಡಿದಾಗ ನಾವು v ವ್ಯಾಲ್ಯೂ 0 ಬಂದಿರ್ತದೆ directly we get the values v is equal to 0 therefore upper term is infinity obviously the lower term will be 0 or infinity ಯಾಕಂದ್ರೆ v 0 ಅಂತ ಪಡ್ಕೊಳ್ಳೋದು v ಬರಿತೀವಿ obviously ಏನಾಗಿರ್ತದೆ v is equal to 0 ಬರುತ್ತೆ so next step ಅಲ್ಲಿ ನೋಡ್ರಿ changes ಆಗ್ತದೆ by 1 equation 1 L of f of t minus a into u of t minus a is equal to by equation 1 L of f of t minus a into u of t minus a that is integration 0 to we write here the values so v is equal to 0 to infinity so e to the power of minus s to t ಜಾಗದಲ್ಲಿ t ಏನು ಬರ್ತೀವಿ v plus a ಬರ್ಕೋತೀವಿ ಓಕೆನಾ v plus a ಆಗುತ್ತೆ then f of v into dv ಆಗುತ್ತೆ ಓಕೆನಾ so obviously dv ಆಗುತ್ತೆ ಓಕೆನಾ so next e to ಎರಡು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ e to the power of minus s a ಹೊರಗೆ ಬಂದಾಗ so ಇವುಗಳ ಇಂಟಿಗ್ರೇಷನ್ ಏನಾಗ್ತದೆ ಅಂದ್ರೆ 0 to infinity e to the power of minus s v ಉಳಿಯುತ್ತೆ ಒಳಗೆ so e to the power of minus s v remains there into f of v into dv okay so dt into dv ಆಯ್ತು ft ಇದು so ಏನಾಗ್ತದೆ obviously this part of this is obviously assumed as definition of lt okay na so now by the definition of lt we assume we see that l of f of t minus a into u of t minus a is equal to ಏನಾಗಿರುತ್ತೆ ನಮ್ಮ value obviously e to the power of minus s a into f of t l of f of t okay l of f of t so obviously questions ಬರೋದು ಬಹಳ ಮಂದಿ ಸರಿ l of f of v ಆಗಬೇಕಾದ್ರೆ ಅಂತ ಹೇಳ್ತೀವಿ so ಇಲ್ಲಿ l of f of v ಆಗಬೇಕಂತಂದ್ರೆ ನಾವು ಆಲ್ರೆಡಿ ತಗೊಂಡಿವಿ by the definition of Laplace transform ಇಲ್ಲಿ ಆರ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಿಲ್ಲ ಉಲ್ಟಾ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ ಬಂದು t is equal to t ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡಾಗ ನಿಮಗೆ ಏನು ಬರ್ತದೆ e to the power of minus st l of only to the integration changes here e to the power of minus st f of t into dt ಆಗ್ತದೆ so all directly l of f of t ಬರೀಬಹುದು so ಈ ತರ ಬರ್ತಾರೆ ನಡೆಯುತ್ತೆ ಇದೊಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡು ಬರ್ತಾರೆ ನಡೆಯುತ್ತೆ obviously lastly we write l of t minus a into u of t minus a is equal to capital F of S. So this is how we prove the second shifting property. So any doubts idru call ಮಾಡಿ ಕೇಳಿ. Okay, thank you.